So today we are going to learn about L'Hopital's rule. You know, it's interesting. I'm pretty sure that's the next section. Let me just double check. I'm pretty sure that's right. But in my master, yes, it is correct. Okay. All right, so we're going to do L'Hopital's rule. And there are two things about L'Hopital's rule. Some of you have seen it before. We want to recognize when we are supposed to use L'Hopital's rule. And then the second objective for today is to identify what terms we call indeterminate forms. And these things can come from quotients, products, subtractions, and powers. And whenever we see them, how to apply L'Hopital's rule. So that's what we're going to be doing today. Okay, so let's talk about first identifying what our indeterminate forms are. So our indeterminate forms are as follows. Their question? Okay, so my system is going to act up today. Oh, let me see. What am I sharing? Okay, I'm only sharing that, so that's fine. All right, I don't know why it's going to act up, but it has its days when it wants to act up, and when it does, I can't do anything about it. All right, so we're going to be identifying indeterminate forms. And for the indeterminate forms, they are in the form of 0 to the 0th power. That does not have a value. Infinity over infinity does not have a value. 0 times infinity does not have a value. Infinity minus infinity, although we might think it is 0, it is not. It does not have a value. 1 to the infinity power does not have a value. You would think it's 1, but no, it's not. 0 to the infinity does not have a value, and neither does infinity to the 0. So whenever you see any one of these things and you do a limit, and your limit comes out to any one of these, you are required to work harder. There's nothing I can say about that. You're going to have to do something else in the problem, and you're going to need to work harder. Okay, so the thing about this, our process, us working harder, let me get rid of that. Okay, so the fact that we have to work harder means we're going to end up using L'Hopital's rule in order to solve this kind of problem. Okay, so that's what work harder is going to mean for us. So let's start off with the first theorem. I'll give you an opportunity to write down what that theorem is. And so our first theorem says that basically, suppose you know that f of a and f of g, I'm sorry, f of a and g of a are both 0. So I want to take a limit. And when we do limits, the thing that we do first is direct substitution. So we will go ahead and just plug in the value. So I'm looking at the limit as x approaches a of f of x over g of x. And the first thing I do is I plug in what a is for f, and I plug in what a is for g. But if I get 0 over 0, that means, I don't know what to do because that's one of my indeterminate forms. Oh, I forgot that one, didn't I? Oh, because this one's supposed to be 0 over 0, not 0 to the 0 power. So that one's wrong. Let's delete that one. That one is actually supposed to be 0 over 0. Okay, so this one is supposed to be, the first one's supposed to be 0 over, what in the world are you doing? Okay, so now let's put in my fraction. So there we go. So this one is actually supposed to be 0 over 0. All right, that's the first one, not 0 to the 0. And that's why this came up here, doesn't belong there. Okay, so if you get 0 over 0, that is not 1. All right, we don't know what 0 over 0 is. So we have to then say, well, let's suppose we can find the derivative at A and the derivative of G at A, and the derivative of G of A is not equal to 0 by itself. Then the way we invoke L'Hopital's rule is that instead of taking the limit as x approaches A of f of x over G of x, we're going to take the limit as x approaches A of f prime of x over G of x, G prime of x. Okay, so what does that mean? That means if I go ahead and try to solve a problem and I get the limit as x approaches A of f of x over G of x is 0 over 0, then the only way I can evaluate this is to then take the derivative of the numerator, take the derivative of the denominator, and reevaluate it and hope I get a number. Okay? So I'll give you a few seconds to write that theorem down. And then we're going to start plowing through some problems. Yes, ma'am. Okay. All right. Okay, I'll figure that out. Okay. All right, so the limit as x approaches 0 of the sine of x over x. So that says, remember, when we do limits, the first thing we do is direct substitution. That means put 0 in there. So this is actually going to give me the sine of 0 over 0. The sine of 0 is 0 over 0. So I now have that first indeterminate form, 0 over 0. And so this thing says to me, I need to work harder because 0 over 0 is not a valid answer. So the next step says, all right, well, let's redo this problem. So my formula, I usually write an arrow that goes like this and put an LH over it so that I know that I am now using L'Hopital's rule. Okay, so L'Hopital's rule says, then if I want to take the limit as x approaches 0 of the sine of x over x, that means I now need to do the limit as x approaches 0, because I got 0 over 0. So here's where I got 0 over 0. It tells me that I need to take the derivative of the numerator. So the derivative of the sine is the cosine. And then the derivative of x is just 1. So now evaluate this. So this becomes the cosine of 0 over 1, which is 1 over 1 equals 1. So now I have an answer. Okay. Any questions about that?
You say you take the derivative of the numerator?
Yes, I am not using the quotient rule.
Okay.
Okay, so L'Hopital's rule, this is not the quotient rule. It is simply to take the derivative of the top function and divide by the derivative of the derivative of the numerator divided by the derivative of the denominator and evaluate those. It is not the quotient rule. Okay. All right, so let's look at the next one. The next one says take the limit as x approaches 0 of e to the x minus 1 over the sine of 2x. So now I'm going to get e to the 0 minus 1 divided by the sine of 0. So e to the 0 minus 1 is 1 minus 1. The sine of 0 is 0. So I get 0 divided by 0. So once again, I have that indeterminate form. Now that I have that indeterminate form, I know that I can use L'Hopital's rule. Okay. So L'Hopital's rule says that then the limit as x approaches 0
I know y'all was best friends like that.
of e to the
You
x.
looking for a nigga who on check? Okay, wait. So I'm confused. What are you looking for?
That's friend.
Okay, yeah, but not. I know we're not talking about him.
Okay, e to the x minus 1 of the sine of 2x, because this is the problem I'm working on. It says take the limit as x approaches 0, but this time you want to take the derivative of the numerator. So the derivative of the numerator, what's the derivative of the numerator? What's the derivative of the numerator?
Is it just e to the x?
It's just e to the x. Thank you very much. And the derivative of the denominator? Derivative of sine of 2x, what is that?
Cos 2x.
Okay, but we have a chain rule. Gotta take the derivative of 2x, so it pulls a 2 out front. Okay. All right, so now I can evaluate this. I get e to the 0 divided by 2 times the cosine of 0. Well, e to the 0 is 1. 2 times the cosine of 0 is 1. So this answer is 1/2. Okay, so this next one, the limit as x approaches 1 of 1 plus the cosine of pi times x. All right, so again, I need to see you evaluate this thing. So I'm going to get 1 minus 1 plus the natural log of 1 divided by 1 plus the cosine of pi times 1 is just the cosine of pi. So I get 1 minus 1 is 0 plus the log of 1. The log of 1 is 0, so I get 0 over 1 plus, and the cosine of pi is -1. So this again gives me 0 over 0. So I have now identified, what's that? That's the wrong color. I was using blue. Try to be consistent. I have now identified my indeterminate form. Okay, so let's invoke L'Hopital's rule because we can. So we got a little arrow that says L'Hopital's rule. So now I get that the limit as x approaches 1 of 1 minus x plus the natural log of x divided by 1 plus the cosine of pi times x. I have to take the derivative of that thing. So this now becomes the limit as x approaches 1. When I take the derivative of 1, that's 0. So I'm just going to get minus 1 plus 1 over x. And then I'm going to divide that by. The 1 is gone. The derivative of the cosine of pi x is going to give me minus pi, the sine of pi x. So now I'm going to put in 1. So I'm going to get negative 1 plus 1. Uh-oh, things are not looking good. Over negative pi. And the sine of pi times 1 is just the sine of pi. The numerator is 0. The sine of pi is 0, so I get 0 over 0. So guess what? I've done this one time again, and again, I got the indeterminate form. So I need to use L'Hopital's rule for a second time. Okay, does everybody see that? So sometimes you may be doing L'Hopital's rule 2-3 times. I think the next time is the last one though. Okay, so we're going to do it again. So therefore the limit as x approaches 1 of 1 minus x plus the natural log of x divided by 1 plus the cosine of pi x says go back and take the derivative of the last thing that we had. So I got to use this one. All right. So the derivative of this in the numerator, so I'm going to get the limit as x approaches 1. In the numerator, I'm going to get minus 1 over x squared. In the denominator, I'm going to get minus pi squared times the cosine of pi x. Okay. All right, so now when I put in 1, I get negative 1 in the numerator. And in the denominator, I get minus pi squared times the cosine of pi. We already know the cosine of pi is negative 1. So this gives me negative 1 over pi squared. And that's finally my answer. Okay. All right, so that one took a little bit of work, but we know taking derivatives is not hard for us. So we were able to handle that one. Okay, so our last one in this section is to take the derivative of this one, and I want you to do that one.